Okay, yesterday we people discussed about the free system and the constraint system. Free system no part is the one in which substance might be one or might be more. Then we were having the differential finite constraints involves restriction on the velocity. However, the finite constraints were those in which there was no restriction imposed on the velocities. Okay. After that, we discussed a remark in which we stated the differential constraints will be linear in velocity, have the expression of the type LK RK vector of RK with respect to T. Okay. We obtained the derivative on both sides. This the linear equation that differential constraint will that we will integrate the equation integrate the constraint, but it is integral and not yk j cap plus kk. RK vector dot, it will be the derivative of the component A, B, K are now here on particle is moving on a particle cannot leave the surface. However, it is to respect to time is 0. Constraint. Now the classification of
हेलो सर, सर आपकी आवाज ब्रेक होके आ रही है।
ओके, yes. So now is it okay?
Yes sir.
Okay. So holonomic system, a system of particles is said to be holonomic. What does it say? That it is not subjected to differential non-integrable constraints. Means that if the constraints are imposed, then those constraints should be not of the type which are differential and non-integrable. What is differential? A constraint which involves the velocity component. And what is non-integrable? Means the a velocity component cannot be removed. Okay, means the differential equation cannot be converted into a finite constraint. Such equations should not be imposed. Means if some constraints are imposed, those constraints should be differential and integrable. It means there should be some restrictions on velocity, but those restrictions cannot be relaxed. And in all, by a holonomic system, with this definition, we can conclude that either the system should be free, means there are no restrictions, or some finite constraints are imposed, means on the velocity component there is no restriction, or if some restrictions are imposed on velocity, then that restriction can be relaxed. Means that very constraint should be integrable. Such a system is known as holonomic system. I am repeating it again. The holonomic system, according to the definition, it should be a system which is not subjected to differential non-integrable constraints. Means such constraints should not be imposed, which are differential and non-integrable. Differential means there are restrictions on velocity. Non-integrable means that restriction cannot be relaxed. So a holonomic system is one of the three types. Either number one, it should be a free system. Second, if the restrictions are imposed, those should be the finite constraints. Third, if differential constraints are imposed, then those constraints should be integrable. Okay, so either there is no restriction on velocity, or if there is restriction on velocity, then that restriction can be relaxed. Such a system is said to be holonomic system. Next one, a non-holonomic system. According to the definition of holonomic system, it should be a system in which the constraints are of the type differential and non-integrable.
एक्सक्यूज मी सर।
Yes.
सर कुछ स्टूडेंट्स की क्लास ज्वाइन नहीं हो रही सर।
But it is auto join.
सर टाइम लगा था, मेरे को भी लगा था टाइम जब ज्वाइन की थी, 4-5 मिनट लोड ही होता रहा।
माइट भी हो सकता है कि जब हम शेयरिंग स्टार्ट कर देते हैं उसकी वजह से इश्यू आया हो।
सर ज्वाइन तो हो रहा है।
हाँ, एक बार उनको कहो कि दोबारा से ट्राई करें। अभी मैं 2 सेकंड के लिए उसी स्क्रीन पे हूं तो हो जाएगा। आई थिंक जब हम स्क्रीन चेंज कर देते हैं तो ज्वाइन होने में दिक्कत आती है। I think we should start now. Okay, so a non-holonomic system is a system of particles on which the differential non-integrable constraints are imposed. Okay, now we are having an example. And in this example, two particles are connected by a rod of length L or 1. Okay, and then it is left to move. Now, there is only one constraint, that the distance between the particles will be always equal to L. And say this L is Ft. The equation for L is Ft. I am repeating again. Two particles are there. Both are joined by a rod. Means one particle is placed at one end of the rod and the second particle is placed at the second end of the rod. And now it is assumed that the particles are moving. Now they are moving freely. But yes, there is one restriction, that the distance between those two particles will be equal to the length of the rod. So there is one constraint equation, and the constraint equation will be R1 minus R2 square will be equal to L square, and L is assumed to be equal to Ft. So it will be R1 minus R2 square minus F square T equal to 0. Or in Cartesian coordinates, it can be written like this: x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square minus F square T is equal to 0. Now, this one is holonomic system. Why? Because there is no restriction on time, velocity. Okay, so this is a holonomic system. Celeronomic, we will discuss it later on. Again, the same thing is given. I think in the previous one, there is a difference. It should be L square. In equation number 23, 24, it should be L square. In next example, it is L is assumed to be Ft. So this time it is R1 minus R2 square minus F square T is equal to 0. This is also holonomic, but it is rheonomic. Today we will discuss it. After that, the next example. In this example, again, two particles are moving in a plane, in the vertical plane. They are just fixed at the ends of the rod of length L, moving, and there is one more condition, we will discuss it later on. First of all, there is one restriction, that the particles are attached to the ends of the rod. So the distance between the particles will be equal to the length of the rod. So the constraint equation will be x1 minus x2 square plus y1 minus y2 square minus L square equal to 0. This will be the first constraint equation. Here we had written z1 minus z2 equal to 0 because we are assuming that the particles are moving in the vertical plane. So the z coordinate is always 0. The next condition, yes. Now go to the statement again. Two particles in a plane are connected by a rod of constant length L. The first constraint is obtained, and are constrained to move in such a manner that the velocity of the midpoint of the rod is in the direction of the rod. What is given? There are two terms only. First thing, velocity of the middle of the rod. Now, if we are assuming one point is x1 x2 x1 y1 and other is y1 x2 y2, so the middle point will be x1 plus x2 by 2 and y1 plus y2 by 2. Its velocity will be x1 dot plus x2 dot by 2 plus y1 dot plus y2 dot by 2. I hope it is clear to you people. I am repeating again. It's an important example. We will discuss it later on in detail. So just try to understand it. What is given? The particles are moving in the plane and fixed at the ends of the rod. So just assume that one point is x1 y1, second point is x2 y2. The first equation is x1 minus x2 square plus y1 minus y2 square minus l square equal to 0. This is the length of the rod. Now next thing, in the second condition, it is given that the velocity of the middle point of the rod will be in the direction of the rod. So we are having two terms here. First thing, velocity of the middle point of the rod. For that, we will find out the middle point of rod and its velocity will be the derivative with respect to t. Now the midpoint is x1 plus x2 by 2, comma y1 plus y2 by 2. And velocity will be x1 dot plus x2 dot by 2, y1 dot plus y2 dot by 2. And it is in the direction of the rod. Now the direction of the rod will be direction ratios, all of you know, x1 minus x2, y1 minus y2. And now the direction of the middle point of the rod and the direction ratios are similar. So their corresponding ratios will be equal. So we obtained the equation number 29. The corresponding ratios x1 dot plus x2 dot by x1 minus x2 is equal to y1 dot plus y2 dot upon y1 minus y2. The velocity of middle point is x1 dot plus x2 dot by 2, y1 dot plus y2 dot by 2. So 2 is cancelled from both sides. And the direction ratios are x1 minus x2, y1 minus y2. These are similar. So their ratios are similar and hence these ratios are equal. Now these are the constraint equations. The first equation is a finite constraint, satisfy the condition of holonomic. But the second condition, in this we are having some terms and this is non-integrable one, because if we will try to integrate, it cannot be integrated. So the second constraint equation involves velocity, x1 dot plus x2 dot, these are the velocities. So the equation number 29 consists of velocities and it cannot be integrated. Therefore, this is a non-holonomic system.
सर ये obtain कैसे की equation 29 dot product या कैसे
क्या
29 equation कैसे obtain किया है?
एक्चुअली क्या किया गौरव कि जो आपकी वेलोसिटी कंपोनेंट था मिड पॉइंट का, आपके पास फर्स्ट पॉइंट है लास्ट पॉइंट है, दोनों का मिड पॉइंट कैलकुलेट किया, उसकी वेलोसिटी क्या होगी, डेरिवेटिव विद रिस्पेक्ट टू टाइम. सो दैट विल बी, हाँ ये आ जाएगा आपका x1 डॉट प्लस x2 डॉट बाई 2, y1 डॉट प्लस y2 डॉट बाई 2. अब गिवन क्या है कि वेलोसिटी जो है मिड पॉइंट की और जो डायरेक्शन ऑफ द रोड है वो दोनों सेम है. ओके, डायरेक्शन ऑफ द रोड क्या है, डायरेक्शन रेशियोज कैसे कैलकुलेट करते थे, अगर फर्स्ट पॉइंट और लास्ट पॉइंट हो तो उनके कॉरस्पॉन्डिंगली डिफरेंस कर देते थे. सो डायरेक्शन रेशियो होंगे x1 माइनस x2, y1 माइनस y2.
यस सर, फिर आगे मतलब
ओके, अब ये दोनों टर्म्स आपकी सिमिलर हैं. जब सिमिलर है तो क्या होगा कि इनके जो कॉरस्पॉन्डिंग रेशियोज होंगे ना वो इक्वल होंगे. सो कॉरस्पॉन्डिंग रेशियोज में क्या हुआ, फर्स्ट कोऑर्डिनेट का रेशियो और सेकंड कोऑर्डिनेट का रेशियो आपका इक्वल आना है. ड्यू टू दैट क्या हो गया कि ये दोनों टर्म्स आपकी इक्वल आ गई.
सर ये बीच में माइनस का साइन है या इक्वलिटी का साइन है?
ओह सॉरी, ये इक्वल का है.
इक्वल टू 0 होगा नहीं तो अगर माइनस,
अदरवाइज इक्वल टू 0 हो जाएगा. ठीक है, अदरवाइज ये इक्वल है. हम आगे चल के एग्जाम्पल करेंगे, उसमें भी इसको इक्वल लेकर के ही हमने वो एग्जाम्पल पे वर्क करना है. ठीक है, सो दीज टू टर्म्स आर इक्वल एंड दिस टाइम अगर मान लो नीचे प्लस होता ना x1 प्लस x2, इसको हम इंटीग्रेट करते तो नीचे फंक्शन होता और ऊपर उसका डेरिवेटिव वो लॉगरिथम ऑफ द फंक्शन हो जाता। बट ये जो इक्वेशन नंबर 29 है ये नॉन इंटीग्रेबल इक्वेशन है, एंड ड्यू टू दिस वी कंक्लूडेड दैट दिस सिस्टम इज ए नॉन होलोनोमिक सिस्टम। Okay, the next one, a bilateral constraint and unilateral constraints. What happens basically, bilateral constraints are those in which the equality holds, and unilateral are those in which there is a sign of inequality. For the example, consider two particles are moving and they are attached at the ends of a rod. So the distance between those two particles will be always equal to the length of the rod. This is the example of the bilateral constraint. But if we are considering one more example, that two particles are moving in a plane or in space, whatever, but they are attached by a thread or by a rope of length L. So in that case, the distance between these two particles will be always less than or equal to L. So this time we are having the sign, inequality sign. Such a constraint is known as unilateral. Okay, but in our syllabi we are going to discuss only the bilateral constraints, means the constraints having the equality sign. But if there is some constraint having the inequality sign, in that case we will consider only those points where equality holds. Means if the particles are attached with the thread, then at some points the distance between the particles will be equal to L. At some points, not at all points. Then to work we will consider only those points where the distance between those two particles is equal to L. We will skip those in which the inequality holds. Okay, and now we will construct a collection of points where equality holds. That very collection will be termed as taut. Okay, in this remark it is discussed that that very term is known as taut. It is said here, taut, where the equality holds. Then the example is given of thread. Now we are moving towards one more important topic, that is the possible and virtual displacement. Okay, shall we leave it today or should we finish it? Okay, let's. I think we should start it tomorrow, so that it will be continued, because first we will define the possible displacement, then possible velocity, then virtual displacement, then virtual then possible acceleration. So we will discuss it tomorrow in the next lecture.
Okay, sir.